cases, depending on if you're going from the left and from the right, and it's like, we usually like this stuff, but don't like this, but you just kind of think about it. You know what I'm saying? If you have an endpoint, and you're coming up to it, and and it's increasing coming up, then that had to be the highest point. And if you're going at the lowest point, the derivative is decreasing the entire time, then it has to be a min. Okay? How are we feeling so far, guys? Any questions? Eric, how are we feeling overall? How's the weekend?
Good.
All right. I'll tell Estelle you said that. It's a little insider right there, buddy. It's a little insider. Okay, so let's look at... That's right. Let's look at another example. So here's a cubic for Amina. Amina said, I just drew this up real quick. So let's do a cubic function, and let's look at all this stuff. So x cubed minus 3x squared minus 9x plus 1, and I want to find the min-max point. Okay, so if I take the derivative, I get 3x squared minus 6x minus 9. And then from here, I need to know when this equals 0. And the majority of my students will absolutely get crushed because they don't know the algebra. People! What happened on that last quiz? We got to know how to do this. And we're going to practice it here. How do we factor or solve for when 3x squared minus 6x minus 9 equals 0? Well, first thing you should do if you want to factor it, some people didn't and they still got it. But if there's any numbers in common, this has a 3 in common, factor it out, and then you can divide it off. Because it's not going to affect the problem at all. And then you play the game. If you want to factor x squared, and I'm going to go over it because we need to, x squared minus 2x minus 3. You want to factor this thing. Here's what I do. I'll write this number here, make a little t, and then I'll say what two numbers multiply to this, and then add to negative 2. So the numbers that, what's going on? Really good? The only combinations that multiply to negative 3 are 1, negative 3, or negative 1 and 3. So which one of these combinations adds to negative 2? So there's your factors. Again, what I do is one step at a time. Again, my little way only works if this is a 1 in front, but that's the majority of the time, so I'll use it. So you can do that. That's fine. You can do whatever you want, but I saw a lot of people that didn't have all method. Do whatever you want. I don't do Pundit squared. Amina does, you do. Okay? I don't. I just do my little T-charts. The way I learned it, we get so stuck on how we learn, you know what, the other ways, I don't care how you did it, you got to be able to factor, because if you get stuck midway through, you did the calculus correctly, but you just can't figure out the zeros, and you know how to do, once you have the zeros, what to do, you know what I'm saying? That would be frustrating to you, David. You know what I'm saying? And I don't want that to happen. I don't want the algebra getting in the way of, I know what to do with it, I know how to take the derivative, I just can't solve for x. That would be frustrating, you know? When you lose a bucket of points because of that. Okay, so when we factor x squared minus 2x minus 3, we get 3 times, so that can just go away. When you're solving for 0, it affects the graph. X minus 3 times x plus 1. Which means the critical points are 3 and negative 1. So on my little chart, I put my negative 1 in, and I put my little 3 in for my x's. So then I only need to check to the right and to the left of negative 1 and 3. Because those are the zeros of the derivative. Does that make sense? That's what you were asking, yes? Okay, so now you have to check a couple different places. Again, what I do, I'm not going to draw since it's the paper here, but you put a 0 here and you put a 0 there. And you only check to the left and to the right. And I usually plug it into this derivative equation just because it's easier to check just the sign, Sandy. And do you remember doing this last year with me? Like the silly little sign chart, you're like, you know, it's like, well, hold on, you're going to come and use it. You guys didn't believe me? Remember? It's ridiculous. Remember when you like blew up, Jesse? You said this is ridiculous? Yeah, that. Well, like, okay, so like, but this is why. So it's like for this application, it's exactly why we're doing it last year. So I take a number to the left of negative 1, like negative 5. Well, at negative 5, this is negative and this is negative. And if I multiply them together, I'm going to get a positive. Does that make sense? I don't care what the value is. I just care about the sign. So this is going to be negative times a negative, which is going to be a positive. If I check a number between -1 and 3, like 0, well, if I plug a 0 into this, I get a negative. If I put a 0 into this, I get a positive. Negative times a positive is a negative. Okay, Katie, how are we feeling with this? Yep? Okay. Again, I don't care what the value is. Stop telling me. I just want to know the sign. I just want to know positive and negative. Okay? I don't care about how fast it's increasing here. I just want to know if it is increasing or decreasing for this purpose. And then, okay, here's 3, so I got to check a number to the right of 3, like 5. This is going to be positive. This is going to be positive. Positive times a positive is positive. So now I know the only places where this original cubic function is increasing, decreasing, and increasing. Okay? And then what's neat about this, you can do, from last year, if you remember the end behavior stuff, this is a cubic function with the lead term positive. It looks like that. Do you know what I'm saying? You can kind of use all this together. This is like x cubed, 3x cubed, whatever. It's the same as like x cubed or x to the 1. It's doing that. And just to see that verified, well, for everything left of -1, this function is increasing. And then between -1 and 3, it's decreasing. And then to the right, it's increasing. You see how, Marco, it matches what we were doing last year? It's doing that. And so, okay, so I did it right. You know, you can verify, yeah, this is correct as far as overall. You know, this function goes like this. Again, I don't know, and I can't tell from this, Roxana, how high or how low, but I just know overall what this thing looks like. Okay? And I know where my local mins and maxes are. Here is going to be a what? Yeah, -1, it's going to be a max, because it goes from increasing to decreasing. This is a max. What about this one? Yeah, and you see, like, and then so if you're looking for a local min or like a low value, then you can only just look here, you know what I'm saying, and plug that x value into the original function to figure out the y value. You see how it all kind of works, stream value, and then on this, to kind of get ideas like where to look. Okay? So, yeah, so that's the first derivative test. First derivative test is a way to tell if something is a min or a max. How do you do that? I'll tell you. First thing you do is check when the derivative equals 0 or undefined. And you make a sign chart from that. Then you use the first derivative to test when the function is increasing or decreasing. Well, whenever the derivative is positive, the function is increasing. Whenever the derivative is negative, the original function is decreasing. So then you can just make a little sign chart, make little hooks and chutes and ladders to see where those local mins and maxes are. Okay? That's the first derivative test. How are we feeling on that?
Good.
David?